All right, I promise you. 2-4 is going to be a bunch better than section 2-3, okay? It is talking about absolute value functions and square roots. We've done some stuff with square roots, but not absolute value, I don't think yet, maybe. The algebraic definition of absolute value is that whatever you plug in is always going to pop out as positive, okay? So you plug a number that is already positive into an absolute value and it pops out as a positive. But you can also plug a number that is negative into an absolute value and it pops out as positive. Here is the technical term of absolute value. So let's say here is 0, okay? Absolute value, the purpose of it is to measure the distance that something is from 0. So if I'm looking at the value of 5 and I'm looking at the value of negative 5, if we're talking about distance from 0, how far is 5 from 0? 5. How far is negative 5 from 0? 5, because you wouldn't say it's a negative 5 feet or whatever it is. That doesn't make any sense. If we're talking about distance from 0, it's always going to be positive. That's what absolute value is. It's the distance from 0. Distance from 0. Okay? Now, that makes things just a little bit confusing. When we have an absolute value equation, we will have two answers always, right? We will have the one that's positive and the one that's negative. Yeah, kind of. Sure. So this is reiterating to you that the absolute value of negative 3 denotes the distance from negative 3 to 0 on the number line. So it is just positive 3.5. Right? The distance that negative 3.5 is from 0 is a positive 3.5. That's why it comes out 3.5 and not negative. Yeah? Yeah. So, definition of absolute value. There it is. Okay. Wait. What? There was no question associated with that. That's just an example. Yeah. There was no question there. Maybe. All right. So, properties of absolute values. We have that the absolute value of some number is the same as, listen, absolute value of some number is the same as the absolute value of the negative of that number, right? Okay. If you multiply two numbers together and take the absolute value, it's the same thing as taking the absolute value first and then multiplying them together. You're going to get the same thing. Example, let's say I have negative 2 times 3, an absolute value. That is going to be positive 6. Listen, positive 6. Which is the same thing as the absolute value of negative 2 times the absolute value of 3. Does that make sense? Yes? So both of those things are the same. That's what example 3 is illustrating. Okay? Same thing with division. If I divide them. So let's use like 4 divided by negative 2. The absolute value of that is 2, which is the same thing as the absolute value of 4 divided by the absolute value of negative 2. I could separate them out and it doesn't matter, right? Right. Okay? Yeah, all of that good stuff, okay? Now, the triangle inequality. One more thing the triangle inequality says is that, all right, here's the triangle inequality. Let me draw you a picture right here. Let's say this is side C and this is side D. And this is the third side, which is the longest side. The longest side, all right? Let me give numbers associated with this so that you can see it. Now, it's not necessarily a hypotenuse because I don't necessarily know that this is a right triangle. So let's say that this guy is 4 and this guy is 6, okay? This guy's 4 and this guy's 6. This is what the triangle inequality says. If C is 4 and D is 6, then this guy has to be less than 10 or equal to 10, right? This guy cannot, for example, be 12, right? If it were 12, we would have a triangle that would look like this. 12 on the bottom, 4 here, 6 here, right? They would not touch each other. Does that make sense? Because 4 and 6, even if you lay them flat, will only make 10, right? So if the bottom side is 12, they will not come together. So if you add the two sides together and it makes 10, this third side has to be less than that, right? That's something that we learned in geometry class. The two sides, any two sides have to be added together bigger than the third side. Yes? You did? But when they use this notation, it makes sense though. It's kind of a 5th grade concept, but when they use this notation, it's hard to understand, right? Maybe? So that third side, a third side has to be The third side has to be less than the two added together. Otherwise, it won't fit together. They will, even if you lay them flat, 4 and 6 will only make 10, and it will not make 12. Yeah? Okay?
Gwen cried all the time. Can't you just do
That's only if it's a right triangle, though. Yeah? Only if it's a right triangle. Okay.
So how do we?
All right. Moving on. We don't care. Moving on. The square root. If you take the square root of something squared, listen. The square root of something squared is the absolute value of that, okay? So watch this real quick. When we're taking the absolute value, or the square root, excuse me, of, let's say I have -2 squared versus the square root of +2 squared. Okay, just wait a second. Okay? If I'm taking the square root of 2 squared, that's the square root of 4, which is
4.
the square root of 4,
It's 2.
which is 2, right? Okay, now hold on just a second. For the second one, if I take the -2 and I square it, that becomes +4, and I take the square root of that, that becomes 2. But, hold on just a second. If I cancel the square root and the square out, it should be -2. Okay, that's why they write it as the absolute value of 2 when you take the square root of something squared. It's because we don't want to lose the negative in there, which is what we would do is if we would square it and then take the square root, right? Okay, this is all just notational things, okay? Don't let these confuse you. If that was confusing, that's okay. We'll go to an example. So, yes. Example 1. Shh. Let's go. Example 1. X minus 4 equals 8. Anytime you have an absolute value, you have 2 cases. Case 1, case 2.
So wait, what was the answer on the last one? Exactly.
There was no answer. There was no question even.
She's showing us how to
The answer is that it's absolute value of 2.
That's the answer there.
Yes. There's no question here. Why is there an answer when there's no
Because you wrote down a question.
No,
she
no, she's showing us.
We were supposed
Where's
to find
your
the other
stripe?
side of the triangle.
No, we
didn't.
didn't.
No, there's
It's greater than or equal to. Look, right there, where it says
This
greater
was
than
not a
or
question.
equal to.
How much your skill?
Okay, all right, here we go. Listen. Listen. You're talking and it's confusing people, okay? Don't talk. Don't speak. Here we go. Listen. This is what this property is saying. It's not asking a question. It's stating a fact. It says, no, quit speaking.
You did an example.
Quit speaking.
Make a run too.
Quit speaking. This is what the property says. It says that if I have 2 sides and I add them together, this one has to be smaller than that one. So I gave you a demonstration as to why that is. This guy right here, if it's 4 and 6, it cannot be 12 because those 2 sides are not going to go together. So because this is a fact, I'm showing you why it works. There's not a question there. That's stating a fact. It's stating a fact, right? 2 squared and the square root is 2. -2 squared and the square root is -2. That's why they write it as the absolute value of 2 and not 2 and -2. Because the absolute value of 2 is -2 and +2. Like represents 2 and -2, +2. Okay, these are just facts. Don't get hung up on them. All right, moving on. Now let's do our first question. This is the first question. This is the first question. All right, here we go. So, first question. You're actually going to get an answer here.
That's what I just said.
There you go. You're going to get an answer here. All right. So the first one says x minus 4 is equal to 8. Absolute value. X minus 4 is equal to 8. So, x minus 4 equals 8. That's my first case. Okay, now, this guy, x minus 4, could be negative. Let me show you why. Don't speak. Don't speak. Don't speak. Okay? X minus 4 is equal to 8. That is just basically dropping the absolute values, okay? So this guy should be the same as that guy, right? If I take the absolute value of negative x plus x minus 4, this is the same thing as that, right? So that's why we have to have 2 separate cases, because the positive and the negative have the same absolute value. So when we're solving for it, we have to have two separate cases. Does that make sense to you? Okay, so pretend that those absolute values are not there. We're going to solve this guy, right? When we make two separate cases, we put them separately so that I can show you how it works or why it's like that. X minus 4 equals 8. Add the 4. X equals 12. One answer. Done. But that's only one answer. We have to then do the other one. So I have negative x minus 4 equals 8. What would you like to do first?
Distribute the negative.
Okay, you can distribute the negative.
Yep.
Most people want to distribute the negative. I'm going to show you how to do something just real quick, different. If you want to distribute the negative after I show you the shortcut, go ahead and do that. But here's something easier. Let's divide by negative 1 and get rid of the negative, right? You can distribute the negative if you want to, but this makes it easier because on this side now, all you have is x minus 4 equals negative 8. Does that make sense? Yeah? It's less negatives that I have to deal with. If I divide the negative over, it's less negatives I have to deal with. Then add the 4. Plus 4 plus 4. X equals negative 4. That's it. Okay? You have to look at both cases because the absolute value of something is the same as the absolute value of the negative of that thing.
Oh my god, we got an answer!
She's being worse. If you were to take the x minus 4, drop it, like if you add the absolute value after it, would you be x plus 4 equals 8, x should equal 4?
It would be negative x plus 4 equals 8.
Why should
Don't even say
Because
that.
both of them should be negative.
I
Both
saw
the
it. I
x
saw our
and the
answer.
You guys don't run whatever.
that both of those things are inside the absolute value. You never switch the sign of both of them.
Exactly.
That would be the equivalent of distributing the negative.
Not very much. Because you just spend
Yes,
half the
Erica.
time
Why
doing
did we
Top
put the absolute
five.
sign from the beginning for
Top five.
You shouldn't have. You shouldn't have.
Oh.
I was just showing you why we have to do both.
Only
The
write what
absolute
she
value.
puts in red.
Only write what I put in red. Okay.
You have to put.
All right, let's solve the next one. Solve the next one. This guy right here is what we are solving, okay? Two cases again because it's absolute value. Case 1.
Is it always going to be
Case 2, always if there's an absolute value. Always two cases, okay? The first case, you just drop straight down. X plus 4 equals 5x minus 2. Done. Drop straight down, okay? The next one, negative parentheses, x plus 4 is equal to 5x minus 2. Okay, so let's do the first case first because that's the easy one, right? Okay, I have 4 pieces. I have 2 sets of x's and 2 sets of numbers, and I want to get them all together. Where do you want to move?
Add to subtract that.
Add the 2, subtract the x. Minus x plus 2 plus 2. He goes away, he goes away. Was that too fast?
No.
No.
Give me yes.
6 equals 4x. I'll slow down. I'll give you a second. Okay? Put the x's together, put the numbers together. Okay? Right. Divide by 4. Divide by 4. X equals 3 over 2, or 1.5. Yeah? Good? Okay, now, what I did on the last problem was to divide the negative over because on that problem, 8 was the only thing over here, right?
Yeah.
But now I have 2 pieces over here.
Can't you do it?
So you can still do it if you want to, but does it make it life any easier? It made life easier for me because there was only 1 piece over here. So do you want to go ahead and distribute the negative?
Yeah.
Doesn't matter. Okay, it doesn't matter. It doesn't matter. Let's distribute the negative. So let's do it. So negative x minus 4 equals 5x minus 2. We'll just go ahead and distribute the negative. I divided the negative over to start with because it made my life a little easier, right? Because 8 is only one number. Okay? That's okay. You want to see it with a negative one? I'll show you how that works here. in just a minute. That's fine. That's fine. Plus x. He goes away. Plus 2 plus 2. 6x equals negative 2.
Just kidding. I messed up.
Okay? Now,
Oh, it's negative 4.
x equals... No.
Nothing, shut up.
Morgan's having a rough day.
Thank you.
Negative 1/3. Did you get that, Morgan?
Yes.
Okay.
I thought the 4 was positive. So then I got...
Okay.
Wow.
All right, now, hold on.
Where's the jean jacket?
Hold on.
I'm not wearing jeans.
Now hold on just a second. It says, you guys aren't listening. Hayden, shut up. It says, check for extraneous solutions.
That means that one right there.
Check for errors. This means plug it back in and see and make sure that it works, because sometimes you will get flukes in there where it will not work. So let's try 3 over 2. 3, or let's call it 1.5. 1.5 plus 4 absolute value equals 5 times 1.5 minus 2. Do you see what I'm doing? Minus 2. Okay, I'm plugging it back in. I'm plugging the three halves back into the equation. Okay? 1.5 plus 4 is 6.5. Absolute value is still 6.5. 5 times 1.5? 7.5? Is it really 7.5 minus 2? No, wrong. 5.5. Bleh, bleh. 7.5 minus 2. So 5.5 equals 5.5. Is that an extraneous solution?
Yep.
No, he's not an error. He is good. We have this guy working. Okay, now let's do this other one. Negative 1/3 plus 4 absolute value equals 5 times 1/3, negative 1/3,
What's the definition?
minus 2. Just wait, it's an error. I'm going to show you right now.
Stupid.
Negative 1/3 plus 4. What's negative 1/3 plus 4? 3 and 2/3. 3 and 2/3. Okay, equals, this guy is 5/3, negative 5/3 minus 2. Right here, negative 5/3 minus 2, yeah? Okay, this is like negative 5/3 minus 6 over 3, if I get a common denominator, right? Negative 5 over 3 minus 6 over 3 is negative 11 over 3. Are those two things the same? So this is not an answer. That is an extraneous
Boom, I told
solution.
you that after you said
There's only
extraneous.
one answer.
So there is only one answer. So plug it back in and check your answer to make sure that it is legit. Yes, ma'am.
If they're going to do that to us, are they going to always tell us to check for the extraneous?
Probably.
Always
Probably.
So basically, you should
Probably,
just
yes.
do the first one and not even bother doing
No, so basically
No,
you
no,
should
no.
do
No, it might be the
both.
first one that's wrong. Or the second one.
So basically you should just do what it says.
So plug it back in. Plug it back in to check to make sure. Okay? It takes 2 seconds. Go to the back.
No, you should go back.
Solving absolute value equations. 2 cases again. Number 1.
Plug it back in.
There you go. There's your 2 cases. 2 cases. 2 cases. Now we have an x squared, which means we have a trinomial.
Oh.
We want to equal it to 0, so we have to move the 2 to the other side.
Do we not have enough room here?
We'll be fine. It's not gonna be too much. We'll move off to the side.
X squared plus 4x equals or negative 5.
X squared plus 4x minus 5 equals 0. Okay?
Yay.
X squared plus 4x minus 5 equals 0. We should be able to factor this guy down. I'm gonna do it over here. We're all right. We're all right. It's fine. We're all right. Okay? What can you multiply to get negative 5 when you add it to give you 4?
4 and 1. Negative 4 and negative 1.
What? What?
Negative 1 and 5.
Negative 1 and 5.
Negative 2.5.
Negative 5 and 3, obviously.
Negative 1 times 5 is negative 5. Negative 1 plus 5 is 4. There we go. Okay? Now, what's x going to be equal to? What's x going to be equal to?
Positive 1 and negative 5.
Positive 1, negative 5. Those are my 2 solutions.
So we have 2 solutions just for the first one.
Those are my 2 solutions. Yes.
Do we have to plunge them back in?
We have to plug both.
It doesn't say
You
so.
are supposed to, but I'm not going to because it doesn't say to check for strings.
We're gonna have 3 answers. 4 answers.
Maybe 4. Maybe 4, yeah. Yeah.
Okay,
So, example 2.
we
What would
divide
you
by
like
1.
to do? Listen, what would you like to do?
Divide by negative 1.
Divide Divide by negative 1. Let's do it. That makes life easier. Divide by negative 1. Divide by negative 1. Woo. Okay. X squared plus 4x minus 3 equals negative 2. There we go. Okay. Then what? Add it on over. X squared plus 4x minus 1 equals 0. Okay. Can we FOIL? Can we factor them down? Well, we multiply to get 1, but we add them to be 4. So what do we have to do instead? You can.
No.
Quadratic formula. Let's do quadratic. Negative b.
So you divide by negative 1, so then your negative 3 should be positive 3.
No. 3 is on the same side. Divide by negative 1, so 2 becomes negative. Okay? Negative b, plus and minus. Square root. B squared minus 4 times 1 times negative 1. All over 2 times 1. Okay, there's my quadratic. Okay? Okay, so let's do the middle part. 16 minus 4 times 1 times negative 1. That's going to be a positive 4 in the end, so that's the square root of 20, right? Square root of 20. So I have negative 4 plus and minus the square root of 20 all over 2. One more thing I can do. The square root of 20 will break down. What's the square root of 20 become? 4 and 5, which is 2 square roots of 5. So 2 square roots of 5. Okay, now, if I want to reduce, I have to be able to reduce in all 3 spots, right? This guy, this guy, this guy.
What? That works out crazy.
That does work out crazy. So, final answer. Negative 2 plus and minus the square root of 5. There he is. Wow. All over 1 if you want to put the 1 on the bottom. You don't have to. Okay, there's that. Right?
So Wayne, guess what? You have 3.
They existed because
Okay.
Good.
Good. What? The negative? The 2? Because it was negative 4 to start with. Negative b. Yep. Good question.
Basically, it's 3.
All right. Example 4. Example 4. Solving a radical. I want to get the radical by itself. What's the radical part?
The part with the square root.
This guy right here. 3x minus 11. Okay, I want to move the 5 to the other side. Minus 5. The square root. 3x minus 11 equals x minus 5. Okay? This is going to be slightly unpleasant, but not as unpleasant as the next one. We're going to skip example 5. So if you want to write across all the way over here, that's fine.
Wow.
Okay, we'll skip example 5. If you want to write all the way across, that's fine. Okay? All right, now what? Now we square. Square. Whoa. 3x minus 11 pops out equals, and whoa, hold on.
X squared minus 25.
Whoa, no.
No.
This means
Oh
x
my
minus
God,
5, x minus 5. Crap.
Woo.
You can't just distribute the square, right? Okay. So that is x squared. If you FOIL, minus 5x plus 25. There you go. Minus 10x. Yes, you can. Yep. So this guy becomes negative 10x. Okay, now let's move it all together. He has a trinomial. He's got a square, an x, and a number. So we got to move it all to one side. So let's take these guys and let's move them over here. Can we do that?
Yeah.
Yep. So minus 3x plus 11 plus 11. 0 equals. All right, help me out here. X squared. 13x plus 36. Beautiful. Okay, now, can that guy break down?
Yeah.
6 and 6
6 and 6 is 12. That's not gonna work. Nope, 12 and 3 won't work.
No, it doesn't work. It doesn't work. Oh, it does work?
It does work.
What else? 3
Why?
and what did I go?
Okay, here we go.
12 and 4.
36, 1 and 36, 2 and 18, 3 and 12, 4 and 4 and 9. 4 and 9. Or 6 and 6, right? But it's 4 and 9.
They're both negative. X minus 4 times X minus 1.
Equals 0. So x equals?
Yeah, Kaden, why is your phone out? Your phone should be in the thing.
Oh my god.
X equals 4, x equals 9. Done.
Yeah, it's
Boom.
behind.
We win.
Yes, it is.
Boom. Okay, next problem.
Yes? Yes?
Trash.
All right, let's skip distance. Let's go straight down to fractions.
Oh, goodness gracious.
Okay? Skip distance, we'll go straight down to fractions. Okay, here we go. This is magical. This is superly magical. Okay? That thing looks disgusting. That thing looks disgusting. Okay? What are you going to do first?
Multiply it over.
Multiply it over. Okay? Shh, stay quiet. We have one problem left. Be quiet, quiet. Multiply the bottom. 2x squared plus 9x minus 5 times 2x squared plus 9x minus 5. This is why it's magical.
Wait. So this totally cancels out that whole second part.
So it totally cancels out that whole bottom part. Did you see that? Boom. Okay, we multiplied the bottom over, but what's 0 times anything?
0.
Still stays 0. Oh my gosh, that simplifies life so much, okay? Now, if you can remember that, you can totally cheat and just set the top equal to 0, right?
Okay,
Because
but
the bottom is going to
Now
cross
what
out
if we
all
divide that by
ways.
0?
But what if?
Oh.
What if Americans are wrong in math?
Friends don't let friends divide by 0.
Thank
But
you.
we're not dividing by 0. We're dividing
Okay.
that.
All right.
We're dividing 0.
Can we factor this?
No,
Can
I
we
actually
factor
remembered
this?
that.
Yes.
How?
Multiply the 6 over.
No.
No.
Negative 1 and
I'm just gonna
She knows what I mean, and she's
She's
like not knowing it.
3.
This is a complex trinomial.
Yeah, so 6 times -1.
Yep.
-6. And then you want 3 and 2 to get 3.
All right. 6, -1. Kate, would you like to lead? I would like you to lead.
I'm just doing
All
exactly.
right.
It should be -3 and +2.
Okay, so 3 and 2 is the combination that we need. 6x squared stays, -1 stays. We want -1 in the middle. So this has got to be -3x plus 2x, yeah? I break it into 4 pieces. This is the factor by grouping. This is Cody's method. Break it down in the middle.
Oh, Cody did.
Add those back together, it becomes -1. Okay. All right, pull out a 3x. Leftover is? I don't want to take out the negative because then he's going to
just leave the negative.
leave the negative because then the x squared would be negative. I don't want to do that. So just take out a 3x, and then leftover is 2x minus 1. 2x minus 1. Yeah. Okay. Now hold on just a second. Shh, watch this. Lots of you guys are getting this wrong. If you can't take anything out, you still take out a +1, like Holly just said. +1.
Why?
2x minus 1. Otherwise, it screws things up. Okay? So, then both of those have a 2x minus 1. And I know I did it right because they're both the same. And 3x plus 1. Now I set that equal to 0. Right? Okay, can you do this in your head? Can you add the 1 divided by 2? Or subtract the 1 divided by 3? Okay, if you can't, you can write it out. That's fine. So add the 1. 2x equals 1. Divide by 2. Divide by 2. X is 1/2. Yeah?
Yes.
Okay? 3x plus 1 equals 0. Subtract the 1. X equals -1/3. There you go. Those are your 2 solutions. Good?
Yeah.
Wait.
Great.
right
Woo!
there.
Awesome. All right, there we go. Done.
This is like the first time.
I know. It's been a long time since we finished.